Okay, so welcome everyone. Thanks first to the organizers for the opportunity to speak here today, and also thank you all for coming. So today I'll be presenting my recent project, which is in collaboration with Mazhar Wasim. Mazhar Wasim is an associate professor at the University of Manchester, UK. And so today I'll be talking about the long-run impacts of In-Utero Ramadan fasting. Before I begin, I just want to say that if you have any questions, feel free to unmute yourselves and jump in at any point during my presentation. Okay, so let me go through a brief introduction before showing you an outline of my presentation. So there is a large literature documenting that gaps in children's skills originate early and persist in later life. And this is so both for cognitive and non-cognitive skills. And some of these gaps originate in the intrauterine environment that humans experience. So the literature identifies different subperiods of pregnancy, which are important for these gaps. And in particular, the fetal origins hypothesis, as it's known in the literature, stipulates that the in-utero period is one of the most critical periods, both for human capital formation, as well as for shaping future health trajectories. And even mild shocks during the in-utero period can leave long-lasting impacts, both on future human capital, as well as future health outcomes. However, establishing causal links between the in-utero environment and later life outcomes is not straightforward. And this is especially so because of two empirical challenges. The first empirical challenge is the measurement challenge. And what this means is that some of the shocks which are used to identify these links, i.e. the links between the in-utero environment and later life outcomes, are quite mild shocks. And so they may not leave strong observable markers. So if one is interested in estimating the impact of such mild shocks, for example, nutritional deprivation or mild disease, but also Ramadan fasting, then one is prone to this challenge. And furthermore, this issue is compounded by potential compensatory investments by parents and society. So because outcomes are measured a long time after the initial shock, some of these initial negative biological effects may have been offset by compensatory investments by either parents or society. And so because of this challenge, it is essential that one measure outcomes with high statistical precision so that even small changes in later life can be detected. The second empirical challenge is that the shocks to the in-utero environment are very rarely exogenous. So for example, exposure to famine, disease, or hunger is likely to be more intense for children who have parents of low socioeconomic status. So for this reason, the future path of earnings is likely to be correlated with these shocks. And so this empirical challenge necessitates some plausibly exogenous variation in the in-utero environment. So in this paper, we exploit the in-utero shock created by Ramadan fasting by pregnant Muslim women. We measure earnings and other labor market outcomes, such as occupation, using administrative tax returns data from Pakistan. And in particular, we used the universe of tax returns filed in Pakistan between 2007 and 2009. So in unison, this
Can I just pause just for a second? We're just looking at an intro slide in a PDF. Is that what we're supposed to be looking at, or do you have a PowerPoint?
Oh, sorry. Let me share differently. I don't know why it didn't. Okay, can you see now?
Oh yeah, that's better. Great.
Sorry. Okay.
It's okay.
Thanks for raising that. So is this the slide you could see? Only?
Yes, we can see that now.
Okay.
Yep.
So okay. I think I said everything that's on these slides, so you shouldn't be missing much. But I'll stay here for a bit longer just so you can see the two empirical challenges. So it's a measurement challenge and the challenge that many of these shocks to the in-utero environment are very rarely exogenous. So one needs both high statistical precision in the measures of outcomes and plausibly exogenous shock to the in-utero environment. So this is essential for the estimation of late life impacts of in-utero shocks. And so we exploit the in-utero shock created by Ramadan fasting by pregnant Muslim women and use administrative tax returns data, as I already described. And so in unison, this plausibly exogenous shock, as I will argue, together with the administrative data, help us overcome both the measurement and identification challenges. And so the main contribution of our paper is to essentially test the fetal origins hypothesis on later life outcomes. And we do so by providing precise causal estimates of the effect of a mild in-utero shock on earnings for a large Muslim population. Furthermore, we're able to investigate some of the underlying mechanisms behind the negative earnings effect that we estimate. Okay, so let me preview some of our results. So we document a long-run negative impact on labor market outcomes. Earnings of Ramadan exposed individuals are significantly lower than the unexposed. So what we find is that exposure in the middle part of pregnancy seems to be particularly harmful, with a negative earnings effect of around 2 to 3%. Moreover, we find that exposed individuals make dominated occupational choices. So for example, we find that individuals exposed in the first 2 trimesters are less likely to be in what we call high-skilled occupations by around 1.25%. We also provide some suggestive evidence about the underlying mechanism, and it seems to highlight the importance of the skills channel, although the complementary health channel may also play its part. So I'll describe this in more detail later in the presentation. So here's the outline of my presentation today. I will start by discussing some of the causal pathways through which the In-Utero Ramadan Fast can impact late life labor market outcomes. I will then describe our data and our empirical strategy. And today, when discussing results, I'd like to focus on our results for labor market outcomes. So in particular, earnings and occupation choice. I will also discuss how the estimated treatment effect varies by treatment intensity. And just very briefly, I'll discuss some of the heterogeneity analysis from our paper. So let me start with some details about the Ramadan fast. So fasting during the lunar month of Ramadan is one of the 5 pillars of Islam, and it's therefore obligatory for all Muslims other than a few exempt categories. So the exempt categories include, for example, the sick, the children, the elderly, but also women who are breastfeeding. The fast involves abstaining from any food or drinks from sunrise to sunset. So the last Ramadan fast in Pakistan occurred in May 2021, and it lasted around 15 hours. So from around 4 a.m. to 7 p.m. So one can think of a number of external shocks to the maternal environment that the fetus or embryo experiences during the Ramadan fast. So apart from the direct effects of fasting that include nutritional disruption and dehydration, the maternal environment is also prone to glucose swings, disturbed sleep pattern, stress, etc. So pregnant women are not expressly exempt, but there is a conditional exemption which allows them to skip the fast if they perceive any harm to either themselves or the baby. However, if they avail themselves of this conditional exemption, they then have to make up for this skipped fast later in the year. Maybe for this reason, observance among pregnant women is quite high. So for a more comprehensive list of surveys, I would refer you to our paper, but the surveys from Pakistan estimate a fasting rate of around 50 to 90%. And that's for fasting for any number of days during Ramadan. The fasting rate is between 30 to 40% for fasting for the entire month of Ramadan during pregnancy. The high-powered studies in this literature estimate a slightly higher fasting rate between 70 to 90%. Okay, so let me briefly outline some of the main biological mechanisms. So there are two main channels by which Ramadan fasting could affect labor market outcomes, such as earnings. And these are health and human capital. So by health, I mean that one may have lower earnings because of coronary heart disease or type 2 diabetes, for example. By human capital, I mean cognitive and non-cognitive skills. And the biomedical literature identifies two main pathways through which the In-Utero Ramadan fast can impact late life outcomes. So these are accelerated starvation and fetal programming. And rather than going through the details, let me give you an example. So undernutrition during pregnancy leads to a reduced number of nephrons in the fetus, where nephrons are the functional unit of kidneys. So initially, this reduction doesn't cause great problems for the fetus or later the offspring. But when aging further decreases the number of nephrons, it may result in either hypertension, but also in further damage to the kidneys. Another important fact that emerges from the biological literature is that most of the harmful health effects do not appear until late in life. There's also growing economics literature estimating the impact of Ramadan fasting. So first, Alman and Mazander 2011 find that Ramadan-exposed children have lower birth weight. So this is extremely important because lower birth weight has been causally linked to a number of important economic outcomes, such as educational attainment, IQ, earnings, and cognitive development. Furthermore, Alman et al. 2015 are able to link in-utero Ramadan exposure directly to educational attainment. And Alman and Mazander 2011, as well as Van Ebbeck 2011, document causal links between Ramadan exposure and health outcomes, including disability. However, there is a paucity of evidence on labor market outcomes. And in particular, there is a lack of precise estimates for the effect on earnings and occupation choice. So this is quite important because it is not clear from this literature if the well-documented early life negative impact persist to later life or if they fade out. And so these initial negative impacts could fade out if there is sufficient compensatory investments by parents or society. And so as I've already previewed some of our results, the answer from this paper is going to be very much no. The early life negative impacts do not fade out, but persist and are reflected both in earnings as well as individuals' occupation choice. Okay, so let me briefly describe our data. So our primary data source is the universe of tax returns filed in Pakistan between 2007 and 2009. And using unique personal identifiers, we merge these tax returns with the tax register, which contains important birth characteristics, including the exact date of birth. So in summary, we observe both the exact birth date as well as earnings for nearly 1 million observations. We have a wide variation in birth years, spanning 66 birth cohorts. And although we don't observe religion of a person, 97% of Pakistan's population is Muslim. Okay. So in addition to these tax returns, we use data from the Demographic and Health Survey. And in particular, we use the ever married women section, which links mothers and children. And it also contains a wealth of information on parental characteristics such as education and wealth. We also use data from the PSLM survey to document the correlation between educational attainment and occupation of Pakistan workers.
I have a question about the tax returns,
Mm-hmm.
and more broadly in Pakistan. How many people are filing tax returns, and does it tend to be a higher income, better educated population, or is this something that most of the population is filing?
Exactly, that's a great question. So in developing countries, including in Pakistan, tax returns data typically only capture the top of the income distribution. So we observe the top decile of earners. Yeah, so it is in no way representative of the population.
Got it. Thank you.
Mm-hmm. Yeah, I'll speak about this in more detail in a minute. Okay, any other questions about our data? Okay, so let me describe our empirical strategy.
Sorry, Linda, it looks like you had a question.
I did. So given that you only have the top decile, and you would guess that those would be the people who would be most likely to mitigate the harm, your findings are probably very conservative.
Exactly. Yeah, that's a point that we're also trying to make. Yeah. Okay. So let me describe our empirical strategy. So a crucial aspect of Ramadan for our empirical strategy is that Ramadan follows the lunar year, which is shorter than the solar year by around 11 days. So each year, the Ramadan lunar month begins 11 days earlier than the previous year's Ramadan. Because of the normal length of pregnancy, children conceived in 9 out of 12 months are exposed to Ramadan, although in different pregnancy months. So this gives us an ideal empirical setting with very natural control groups. So we compare earnings of exposed individuals to the earnings of the unexposed individuals. And we do so after conditioning on the place, month, and year of birth in order to make very granular comparisons. Furthermore, the slow passage of Ramadan through the Western calendar and our access to 66 birth cohorts enable us to control for birth seasonality non-parametrically. So what I mean by this is that because Ramadan begins 11 days earlier than the previous year's Ramadan, it will complete a full cycle around the Western calendar in 33 years. And so if one has access to 33 birth cohorts, one is able to disentangle the effects of birth seasonality from the effects of the Ramadan fast. And we can do so because we observe 66 birth cohorts, which covers 2 full cycles of Ramadan through the Western calendar. Okay. So let me now move to, I think, question by Linda. So since we don't observe fasting behavior, because we use text data, we don't estimate the average treatment effect, but we estimate the intent to treat effects. So there's a number of reasons why our ITT estimates should be interpreted as lower bounds for the average treatment effect. So first, the fasting rate is lower than 100%. So under some assumptions, the average treatment effect is just the ITT, the intent to treat effect, divided by the fasting rate. And so because the fasting rate is lower than 100%, the ITT will understate the ATE. Secondly, our ITT estimates would understate the ATE if there is compensatory investment by parents or society. And this seems particularly likely in our sample because we use tax returns data. And so in tax returns data, in developing countries, tax returns data typically capture only the top of the income distribution. And so by intergenerational persistence of income, because we only observe richer children, these will on average have had richer parents and hence laxer budget constraints and therefore a greater ability to invest in their children. So a greater ability to mitigate the initial negative impacts of Ramadan fast. Another point I would like to highlight before showing you our estimates is that the fasting rate may vary across different pregnancy months, which we don't observe. And so one thing to keep in mind when I show you our ITT estimates is that the difference between the ITT estimates and the average treatment effect would vary across the different pregnancy months. Okay, so let me now describe how we construct our exposure measures. So remember that we observe the exact date of birth in our tax returns data. We of course don't observe the date of conception, and so we calculate it by subtracting the normal gestation length of 266 days from the exact date of birth that we observe. And we combine this calculated date of conception with the timing of Ramadan in a given year to divide our sample into different groups based on their exposure period. And so an exposure period in our paper is either an exposure month or an exposure trimester. And we compare outcomes of the certainly not exposed group with other groups by estimating the following model. So Y, the dependent variable here, you can think of as, for example, log earnings, and EM is the exposure month. Mu spans from -2 to 9, and these are the 12 different exposure month categories. So EM exposure month 1 to 9 corresponds to individuals which were exposed in pregnancy month 1 to 9. Groups -2 and -1 are not exposed, and group 0 is only partially exposed. Because we have a large sample, we use only group -2, so those exposed in exposure month -2 as our control group, and we keep the groups -1 and 0 in our specification as placebo tests. So if there's any variation in the parental composition across exposure months, the coefficients beta -1 and beta 0 will pick that up. So it's a placebo test, a test for our identifying assumption. Okay. We also use 3 sets of controls. So the gamma here is district of birth fixed effects, eta is month of birth fixed effects, and lambda is year of birth fixed effects. So when I show you results, I will typically, I will first show you the baseline, which includes none of these fixed effects, after which I will successively add each one of these three fixed effects. And so using all three of these fixed effects is our preferred specification because it is the most granular comparison. So here is a visualization of the construction of our exposure dummies. So on the x-axis, you can see the 12 different exposure months. And on the left-hand side y-axis, you can see the conception date. And this is for an example year, 1974. And so you can see, using this example year, how different conception dates map each individual into particular exposure months. The green lines correspond to the Ramadan Fast during this year, so in 1974. And so if you're conceived far enough from Ramadan, you will only be exposed in the final month. That's why your exposure month is 9. And then as your date of conception moves closer to Ramadan, the individual will be exposed in increasingly earlier parts of pregnancy. So the final group is the partially exposed, which is only exposed for the final weeks or days of pregnancy, strictly less than 1 full month. And finally, you can see groups -2 and -1, which are not exposed. So one advantage of using only group -2 as our control group is that this group would only be misclassified if the pregnancy lasts longer than 295 days. And so this is an extremely unlikely event. Another important feature of this strategy that I like to highlight is that premature births cannot be misclassified as not exposed using this strategy. I can talk about this in more detail if you have questions, but for now, I'll move on. So in this research design, identification requires that the unobserved determinants of earnings are uncorrelated with our Ramadan exposure dummies. So this means that the timing of conception in terms of the lunar calendar must be as good as randomly assigned. And so here, Hijra calendar is another term for lunar or Islamic calendar. So for example, this identifying assumption would be violated if parents systematically time pregnancies to limit or completely avoid Ramadan exposure of their children. And so we will explore this identifying assumption using the DHS data. So on the left-hand side, you can see the distribution of births across the Western calendar. And so you can see there's strong patterns of seasonality across the Western calendar. So some months have heaps where the proportion of births is much higher than the proportion of births in other months. In contrast, the distribution of births across the lunar calendar is close to uniform. So there are no heaves or throws in particular exposure months. So we interpret this as consistent with there being no variation in the birth rate across the lunar calendar. So
Tim, can I interrupt you just for a second? There's a question in the chat about your prior slide from Lucas. Why stop at 9 months? Can you look at effects for months after birth as well?
Okay, so why stop at 9 months? So we could continue, but so let's look at this example year, 1974. So exposure group, the group that is exposed in month 9 is born in these conception dates. If we move further down to earlier conception dates, this group will just not be exposed, right? So this will be again group -2. So I think a good way to answer the question is just using this graph. And so you can see that each year we move from exposure month -2 back to 9.
I think you also mentioned, Tim, that women who are breastfeeding are exempt from Ramadan, right? So
Yes.
looking at months afterwards would be less helpful.
Okay, that's what I had in mind. Okay, but in theory, you can compare. Like, let's say someone was born 1 month before Ramadan and 1 month after, and you can compare these two people across their whole lives, right?
Oh yes, I see what you mean now. Yeah. So the answer to that question is very much that we don't expect breastfeeding women to be fasting during Ramadan because there's an unconditional exemption.
Thank you.
Yeah, thanks for the question. Okay. So we stopped here where we find evidence that is consistent with no variation in the birth rate across the lunar calendar. However, no variation in the birth rate across the lunar calendar does not preclude that parents of certain characteristics sort into specific exposure months. So again, we now test this formally, first using the Western calendar as a benchmark, and then using the lunar calendar. So in this table, in the top bar, you can see different indicators of socioeconomic status of parents. And we regress each of these indicators individually on the different quarters of birth in the Western calendar. First using no fixed effects, and then using all three of our fixed effects. And so unsurprisingly, what emerges is that parents of certain characteristics seem to sort into specific quarters of birth depending on their socioeconomic status. Okay, so the p-values are essentially like very close to zero, and we can reject in all of the tests that we perform. So here I show you 10 tests, altogether we do 20, and we can always reject. In contrast, when we now do this exercise for the lunar calendar, all of these correlations essentially break down. So here we use exposure trimester dummies rather than exposure months, but we also do so with exposure months. And so first, second, and third trimester corresponds to sets of 3 months to the appropriate exposure months, essentially. And we group exposure month -1 and 0 into the category no or partial exposure. And exposure month -2 is again the omitted category, our control group. And so none of the individual coefficients are statistically significant. And we can also never reject the null that all of these exposure trimesters have jointly 0 coefficients. Okay. To explore this further, we estimate a multinomial logit model where we regress the exposure trimester on all of these indicators in one single specification. And again, we find evidence that that is not consistent with there being any sorting of parents into particular exposure months or trimesters. Okay. Any questions here? Okay. So let me now discuss our results. So I'll begin with our results on earnings, and I will first show you some non-parametric evidence before showing you the results of our regression from the specification that I've outlined. So on this bin scatter plot, you can see the distribution of mean earnings across exposure weeks. So we divide our sample here into 52 different exposure weeks. The vertical green line corresponds to the first exposure week. The horizontal green line simply corresponds to the minimum of earnings in a given exposure week. And the red line fits a local linear kernel on the scatter plot. So what we find is a saucer-shaped relationship between mean earnings and exposure week. So we find that mean earnings monotonically decrease with Ramadan exposure up to exposure week 15, where they reach a minimum before they start rising again. Okay. And so this earnings exposure profile doesn't only hold for the mean earnings, but also holds for other moments of the earnings distribution. So here we perform the same exercise using the first, second, and third quartile of the earnings distribution. And again, we find this saucer-shaped relationship between earnings and Ramadan exposure. And obviously there's a difference in levels because we look at different quartiles, but the shape remains consistently the same. So now we refine this analysis by adding our different fixed effects. So first, here we regress log earnings on exposure months without any fixed effects. That's our baseline. So now we use exposure months as in our specification. So we see this, we again find this saucer-shaped relationship between earnings and exposure months. And the gray shading corresponds to the 95th confidence interval. So we now refine this analysis by adding successively fixed effects. So first we add month of birth fixed effects, which don't change this relationship meaningfully. The same is true for district of birth fixed effects. However, year of birth fixed effects flatten the earnings exposure profile considerably. So there is no longer any meaningful difference between exposure in the early months of pregnancy, in the final month of pregnancy, and those who are unexposed. In contrast, those who are exposed in the middle part of pregnancy continue to have significantly lower earnings. So the reason why the earnings exposure profile flattens once we add birth covariates, i.e. the year of birth fixed effect, is that we are now accounting for any differences in experience. So we are no longer comparing potentially younger to older individuals. We now include year of birth fixed effect. Okay, and so here are the results from our regression using the specification that I've shown you. So we regress log earnings on the different exposure month dummies. First, using no fixed effects in column 1. That's the most parsimonious specification. And then we add different permutations of fixed effects to see if the estimates change before reaching our preferred specification in column 6, which uses all 3 fixed effects, i.e. month, district, and year of birth. And so there are 4 facts that I would like to highlight on this table. So first, we can reject the null that the coefficients on all of these exposure months are jointly 0 in all of the specifications. Second, looking at the result on column 6, which is our preferred specification, we can see that the earnings of those exposed in pregnancy month 3 to 8 are significantly lower. And those who are exposed in pregnancy month 5 seem to be most negatively exposed, with the negative earnings effect of -3%. We can also see that those exposed in month 9 do not seem to be affected. And so this may be because the fetus has already matured enough and so is not as vulnerable. And finally, the coefficients on exposure months 0 and -1 are indistinguishable from 0 in our preferred specification. So this is consistent with our identifying assumption, and it's consistent with there being no variation in parental characteristics across the different exposure months. Okay. Any questions about these results? Yeah.
Go ahead, Linda, and then I have a follow-up question as well.
So what's going on with the month 4 in model 6?
Yeah, so the effect size is as expected, but it is not statistically significant. So yeah, I mean, it could be a number of things. So could be that the fasting rate is lower, for example, but it could also be that the actual ATE is lower, but we're not able to distinguish.
Are there any differences by gender of baby?
So, because that's a good question. So we explore, the literature identifies one potential impact of Ramadan fasting, which is to skew the sex ratio towards females. And so we test that hypothesis and find no significant effect. Secondly, and I guess I think this is more close to what you're asking, we cannot really look at gender, we cannot really specify or run the specification for different genders because we do not observe many women. Our sample is more than 90% male because we use tax returns data from Pakistan. And also the labor force participation of women in Pakistan is generally very low. So it's around 25%. But that's a great idea, and I think we should explore this further.
Thanks.
Can I ask a question about your sample? So you have, let me turn my video on. So you have in your sample are people who respond to pay, who formally pay taxes, right?
Yes.
So it's like pretty rich, I would assume, like the 20% richer in the country or something.
Yeah. So it's roughly the top decile.
Top decile. Okay. So yeah, I'm thinking like so these people are definitely not starving. Like they definitely have like enough consumption. I mean, they're doing Ramadan, but they're not like having any like budget constraint on buying food, right? Because it would be very interesting if you had some data set that included the rest of the 90% of the population or the lower ones, which would be people who are more in poverty. Because I would assume, like, let's say you eat enough, so you can have like some sort of like your body has some fat, and then you are better able to cope with the effects. But then if you're like sort of starving, then I would assume the effects are bigger, right? So like you're kind of looking at the place that is least likely to have an effect, right? Of the rich people in the country, because those are the ones in your data. So yeah, that was one thing. The other thing is that I was wondering about this 4th month as well. Like if this could be like, because if you look at the standard errors, they reject, like you would expect a continuity, right? But even the point estimate is quite different between months 3 and 5 and 4. And then like it would be in the, let's say, assume it was to like 0.26 or some average between month 3 and 4, then your point estimate, if you construct the confidence interval around it, the linear interpolation will be outside of it. I don't know, it's kind of weird. I'm thinking like, I don't know if this new difference in difference econometrics things would give you like slightly different confidence intervals, and I'm kind of worried about this a little bit.
Okay, yeah, noted. So we don't observe this drop when we pull the exposure months together in our trimester results. But that's, I don't think that answers your question. Yeah, so but in the trimester results, obviously, yeah, there is continuity in the profile.
Just to follow up Lucas's point, is there any reason that women might be more likely to take the exemption, the voluntary exemption in month 4? Is there anything cultural that they'd be starting to show by then? It might be worth looking into to see if there's some kind of explanation. I mean, anything.
Yeah, no, that's a great idea. Yeah.
My other question, kind of pertaining to this, but I don't know how much clinical data you have available in the health data set that you're pairing. Do you have any blood markers of nutrition or other health characteristics of the mother that might help you detect some of these issues Lucas was describing? So for example, iron deficiency that maybe didn't appear until the middle, the 2nd trimester because they had enough stores initially, or other health conditions that developed in the 2nd trimester, like maternal gestational diabetes or something like that, that could be playing a role in the health of the mother who maybe could or could not tolerate the fasting as well and could have impacted the baby's health?
Yeah, so we don't use any health outcomes from the demographic and health survey. Yeah, so I guess we're simply not trying to estimate those effects, but it would be interesting to look at.
Maybe more for follow-up studies into.
And do you have any household surveys that you could leverage?
So the DHS is a household survey that we're using, but we're using it only to see if parents with different socioeconomic characteristics time their pregnancies in particular ways to limit.
Okay, but does it also have the birth date of every person?
Yeah, so it doesn't. So yeah, that's an excellent question. So it doesn't. We only observe exact date of birth for around 8% of the sample. So we impute date of birth to be 15 in the rest of the sample, and we also do a number of robustness checks. But it does include the exact month of birth for most of the sample. So the month of birth itself can tell you a lot about it.
Okay, but why aren't you using just the survey, and then you can look at the whole population instead of just looking at the top 10%?
I see. So we could replicate this analysis using the DHS. However, on different, we'd be using different outcomes. And so our question is very much, what are the impacts on labor market outcomes? And
But
so,
this household survey doesn't have like earnings questions, anything like that?
well, yeah, no. So we observe mothers. So mothers are surveyed about their children, but there is no follow-up on the children later in their when they join the labor market. So we know when the children were born, but there's no, they are not part of the survey.
I was thinking you could get like a regular household survey that had a question on the birth date of the person, and then you wouldn't have information on the mother or the parent. So it's nice that you have this other survey that validates that. But if you get like any household survey that has any question on earnings, then you could, including informal earnings, which I assume are very big. Then you could look at this for the, let's say, the lower part of the income distribution, which I think would be interesting.
But the advantage of this data set is that there's so many cases. And, you know, DHS would have a few thousand, and here you have 1 million. So it's a good point, though. Just you're much less likely to pick anything up if it's subtle. But maybe,
Yeah,
as you said, at the lower, at lower socioeconomic statuses, it's probably a bigger effect. So including those might allow you to pick up more.
Yeah, you could do like a power calculation here and try to see what's the effect that you would detect under different sample sizes. And that would sort of like let you know if you should expect something. And then, yeah, anyway, sorry.
Okay, yeah, thanks for the suggestion. Okay. So let me briefly discuss how the estimated treatment effect varies by treatment intensity. So in the text data, we don't observe family religiousness or fasting behavior. So we use a proxy for exposure intensity, where we define a family as more likely to fast if the given name of the individual is Muhammad. So we essentially presume that more religious mothers are more likely to give a religious name to their son, but also more likely to fast. Okay. And so here are the point estimates for the two different treatment intensity groups. So what we find is that the point estimates are consistent with our a priori reasoning. So the effect size is invariably larger in magnitude for the high treatment intensity group, the group with the higher expected fasting rate. Having said that, the difference between the two treatment intensity groups is not always statistically significant. But one point that I would like to highlight is that this positive relationship between exposure intensity and the effect size strengthens our causal story. So linking In-Utero Ramadan exposure to late life labor market outcomes.
And I want to point out that month 4 fits right in there with the pattern. It's not lower. I mean, it's a little bit, I guess you do see it here. There's a little bit lower effect, especially for the blue.
This is not your preferred specification, right? This is not the one that is
Yeah.
generated.
Yeah, so let me show you our preferred specification. So again, month of birth and district of birth fixed effects don't change this profile in any meaningful way, but the year of birth fixed effects, again, matter a lot, and they flatten the profile considerably. So for the low, I guess here in exposure month 4,
That's where it is. Yeah. So did something change in the likelihood that women fasted, because this year of birth effect seems to be eliminating the month 4 significant effect? So maybe there was a change in the observation for time, because the year of birth effect, then without the year of birth effect, you get it, and with year of birth effect, you don't. So what is it about when the different cohorts that was there a change in the fasting and how people fasted?
Is it possible, actually, Linda, for him to just rerun this model in, people who were born in the 70s, 80s, 90s,
Sure.
and just see if you see the same observations? I'm sure earnings changed over time, and people moved through various SES classes at that time, throughout the time.
Yeah, I was going to suggest something like that, doing cohort by cohort, because our sample size is probably big enough, I would assume. Since you're including these fixed effects, I guess is equivalent to running like separate estimates for each cohort, or maybe grouping by decade or 5 years or something.
Yeah.
And also there's a point about I don't know how far back your data goes, but the age of the people, because the sort of like income inequality across cohorts, within the life cycle of a cohort tends to increase with the age, right? So you would expect this sort of difference, especially because we're talking about rich people, right? We're talking about the upper 10% versus the 1%. So you see the changes are increasing over time as people, like some people become directors and some people become like regular workers. So you would expect this to sort of only show up in later cohorts. And then you could also have a heterogeneity on how like the behaviors of mothers in the 70s, the 80s, the 90s, that probably as well. So I think it would be interesting.
Or even age of mother at the time of birth too. A young, healthy woman versus someone in their late 30s.
Yeah, so that's very interesting. One point I'd like to make: we cannot condition on age too much, because once if we, for example, only compare people decade to decade, we can no longer control for birth seasonality, right? So we need as many birth cohorts as possible to control for seasonality effects.
How big are the seasonality effects empirically?
So quite large. This
Okay.
season of birth has been linked to a number of important outcomes, so like education, for example, etc.
Okay.
So these should be important in our context. Yeah.
And how about the effect at -1? Like, how are you rationalizing this?
So in this preferred specification, well, the difference between the two, I think this is definitely something we have to explore more. So the high treatment intensity group confidence interval doesn't include 0. So the identifying assumption may not, this isn't consistent with the identifying assumption for the high treatment intensity group. But that's, this is a heterogeneity analysis. Okay, so let me now discuss our results. for occupation choice. So we essentially ask two questions. First, does Ramadan exposure lead to dominated occupation choices? So we define occupation choice using two different variables. So we look at being employed rather than self-employed, and also being in a high-skill occupation rather than a lower-skill occupation. And so employees in Pakistan are on average more educated and earn considerably more than the self-employed. So in developing countries, employment, and in particular employment in the public sector, is linked with status, and therefore attracts on average more educated and able individuals. And so this is something that we also show formally. So we examine how the propensity to be an employee, as well as the propensity to be in the top of the income distribution, varies with Ramadan exposure. And for our second definition of occupation choice, we use the 6-digit occupations codes that are available in our text data, and we divide our sample into high and low skilled categories. And the second question that we ask is, can the negative earnings effect that we estimate be explained by these dominated occupation choices? So let's start with the first question. Yeah, questions? No? Okay. So let's start with the first question. So on this in this table, columns 1 and 2 regress the propensity to be an employee on different exposure trimester dummies. And what we find is that the propensity to be an employee, which is the dominant occupation choice, decreases with Ramadan exposure. So especially for those who are exposed in the first 2 trimesters, their propensity to be an employee is lower by around 0.7 percentage points. Next, the columns from 3 to 8 regress the propensity to be at the top of the income distribution, again on these exposure dummies. And what emerges is that the proportion of top earners falls with Ramadan exposure, especially for those who are exposed in the second trimester. Okay, so let me now show formally that employment attracts on average more educated individuals. So here we use the PSLM survey. We regress an indicator for being an employee on different education attainment variables. And so we find that the probability of being an employee rises sharply with one's educational attainment. So for example, individuals with at least an undergraduate degree are 14 percentage points more likely to be employees rather than self-employed. And these educational differences in turn show up in the earnings that these individuals make. So here we compare the distribution of earnings of employees to the distribution of earnings of the self-employed. And so the distribution of earnings of employees dominates the earnings of the self-employed, other than at the extreme bottom. This is using our text data. Okay, so now we use our second measure, which divides the sample into high and low skilled categories. So we regress an indicator for being in a high skilled occupation, again on these exposure trimesters. And we find that the propensity to be in a high skilled occupation, again, falls with Ramadan exposure. So this evidence answers our first question. In particular, Ramadan exposure does seem to lead to dominated occupation choices. There's a question in the chat, just remember how to put it, okay. Okay, so we now move on to our second question. Another question?
Yeah, what happened to all the rest of your cases? I thought you had observations on 1 million people.
Okay, we don't observe occupation for everyone for whom we observe earnings.
Okay.
Yeah, but yeah, this is a part of the paper where we're currently also working on documenting the differences between these elements. Okay, so let me now move on to the second question. Can the negative earnings effects that we estimate be explained by these dominated occupation choices that exposed individuals make? So to explore this, we regress again log earnings on exposure trimesters, but now within employees. So this uses only the sample of employees. And what emerges is that there are significant differences in earnings even within employees. And this suggests that occupation choice alone cannot explain the negative earnings effect that we estimate. And now, once again, we now use the high skilled variable, and we regress log earnings on exposure trimesters within high skill occupations. Again, we find that the earnings of exposed individuals are considerably lower even within high skilled comparisons. Okay, so this implies that occupation choice alone, again, does not cannot alone explain the negative earnings effect that we estimate. So let me now collect these results. So apart from finding that Ramadan exposed individuals make lower earnings, we also find that exposed individuals are less likely to be employees, to be in high skill occupations, and to be at the top of the earnings distribution. And not only are exposed individuals less likely to be employees, they earn significantly less conditional on being employees. And the same is true for the high skilled comparison. So not only are exposed individuals less likely to be in high skill occupations, but they also earn less conditional on being in a high skill occupation. So this evidence, yeah, Linda, question?
So no, just a comment. So that suggests that the damage that's done cannot be fully mitigated, because the families that have the most incentive to do it and the most resources to do it are not able to do it completely. That's really incredible.
Yeah, I agree. So the evidence is consistent with Ramadan exposed individuals having on average lower endowment of cognitive and non-cognitive skills, which then reflects in their occupation choice and in their earnings within occupation choices. And so we provide suggestive evidence that the earnings effect mediates through the skills channel, but we cannot rule out other mechanisms such as health. So we by no means can separately identify the individual contributions of the skills versus health channel and speak to which one is more important. We only suggest that the skills channel is important. And this is solely for two reasons. So first, the dominated occupation choice that exposed individuals make is strongly correlated with educational attainment. So they seem to make occupational choices which are strongly correlated with lower education. And although we don't observe education in our tax returns data, and so we cannot link exposure, education, and earnings together in one sample, most of the harmful health effects do not appear until late in life. And so it is unlikely that exposed individuals make dominated occupation choice because of the harmful health effects, rather than because of lower endowment of skills. Okay, so let me very briefly discuss some of our heterogeneity.
Can I ask a question?
Yeah.
So are you guys the first ones to do anything on Ramadan and impact? Like is there any paper on education already? Is that what you're referring to?
Yes. So there are papers that look at impacts on education. And so one of the motivations of this paper is to see if the well-documented effects on education persist to later life or if they fade out. And so this evidence and this suggested a channel is consistent with the literature on education. Okay.
The other question is, how does this compare with other estimates from the literature from droughts and like are your sort of magnitudes sort of coherent to other effects of like from the literature?
Okay, so we are still working on the best way to compare the magnitude of this paper to other papers. And part of the reason why we're still working on this is that the literature is quite large. But one sense of magnitude that I can give you is that if you take a conservative estimate of a 6% return to education, being exposed to the Ramadan fast in the middle part of pregnancy is equivalent to having half a year less of education.
I was thinking more like there are these papers on droughts, and then they look at the outcomes of the adults. And then like droughts on when the kid was in utero, and then they look at the long-term impacts. And then I think you should sort of put your results into perspective to see if they're plausible. Maybe that's like an extreme comparison, because here is more like a time of the day when you eat, and there's actually like lack of food for like a prolonged period. So it should be lower than those. But if your results are sort of like very close to those, it's harder to believe, because then like I'm thinking of what I think would be the biology of this, which I don't actually know, but come on.
Mm-hmm. I see. Yeah, that's a great suggestion. Thank you. Okay, so let me briefly just show you some of the heterogeneity analysis. So we explore heterogeneity and the treatment effect along 3 dimensions. We compare younger to older cohorts. We look at fasting during extreme weather, i.e. during the 2 hottest and driest months. And we look at births in one of the 3 richest cities, where we use birth in a rich city as a proxy for parental income. Because on average, parents in the 3 richest cities have a higher ability to make compensatory investments. And what we find is that the effect size is higher for older cohorts. So this is consistent with the biomedical literature, and it's consistent with the idea that the health effects, the harmful health effects, may have at this point started to kick in. The effect size is also higher for more difficult fasts and for children of lower SES parents. So for children born outside of the 3 richest cities. And as I already mentioned, we also explore the effect of Ramadan exposure on the sex ratio, and we find no significant effect. So we don't find that Ramadan exposure skews the gender ratio towards females. Okay, so this is just a brief overview, and I'd be happy to hear if you have any suggestions about, any more suggestions about potential heterogeneity analyses. Okay, so let me briefly conclude. So we estimate the effects of in-utero Ramadan exposure on later life outcomes. Among other things, we find that it lowers earnings of the exposed individuals by at least 2 to 3%. Moreover, we find that exposed individuals are also less likely to be employees, to be in high-skill occupations, and to be at the top of the income distribution. We provide suggestive evidence about the importance of the skills channel, although the complementary health channel may also play its part. And so why is this important? So surveys show widespread misperceptions about the optional nature of Ramadan fasting for pregnant women, and also about the potential long-term impacts on child's future outcomes. And Ramadan is a mild shock, but it affects 1.35 billion people globally. And so eliminating these misperceptions could generate huge Pareto gains on the order of $2 billion in Pakistan and $14 billion globally. Okay, and so as I said, given a conservative estimate of a 6% return to education, in-utero Ramadan exposure in the middle period of pregnancy is equivalent to having half a year less of education. Okay, so that's all. Thank you very much. And happy to answer any more questions or comments.
Tim, thank you so much. This is incredibly interesting work. I am kind of at a loss for words, because I'm like, how would you even affect policy at this level? I mean, these are culturally very, very ingrained ideas, adopted strategy, you know. I'm just curious to think what the downstream effects, you know, where you could take this and how you could communicate this and disseminate the information to actually improve care. What are your thoughts on that? And Linda, also sounds like you have a follow-up question as well.
I absolutely do. So in Jewish religious law, and you know, Jewish and Muslim religious law is often very closely connected, you have an obligation to safeguard your health. So when it became known, for example, that smoking was harmful to health, then it became a religious obligation to not smoke. So if it became known, especially by religious leaders, that this was causing long-term damage in men, the men born when their mothers were fasting, I think fasting would quickly become mandatory for pregnant women. I mean, missing the fast, skipping the fast would become mandatory, like it is for breastfeeding women, just a blanket exemption.
Yeah, so to answer, one of the points we make in the paper is that these are all protected beliefs. And so any policy must be aware of this and be careful. However, I mean, one policy implication seems to be to target these misperceptions with information. So there, in a survey in Pakistan by Mubin et al. 2012, 88% of surveyed women reported that they think it's obligatory to fast during pregnancy, right? Which is simply not true. They're conditionally exempt if they perceive any harm. And also 60% of the surveyed women reported they don't perceive any harm from fasting. And so this may well be the case, but they may not be aware of the long-term negative impacts on offspring.
I mean, I'm speaking totally out of context and without any experience here, so please recognize this as being a very naive question, but I think educating women on this is really helpful, but educating the religious groups who have a huge impact, I imagine, on how people think and even the guilt that they feel for not following certain rules, even if they feel like it's health-wise would be appropriate, they might feel guilted into following the religious leaders' recommendations. I don't really know anything about this, within the context of the Muslim faith. So just with a grain of salt, it seems like an educational intervention addressed at mothers would just be one very small part of what we would need to really improve health of these children. Yeah, so that definitely encouraging, for example, local imams to create awareness about this topic is definitely one of the possible and policy implications. Yeah. I almost wonder too, from this is happening as we speak. And so there's plenty of children out there who are now going to have Ramadan exposure in utero born. And, the point at which, say, a pediatrician is screening for this prior exposure and maybe even introducing them to early education interventions when their brain is the most malleable, could potentially help with some of these, effects that they could have had. Yeah, I think it's also surprising how high the fasting rate is in Western countries as well. But again, apart from Ramadan fasting pregnant women, this also applies to pregnant women who, for example, skip meals, skip breakfast, etc. Absolutely. Or on a diet during pregnancy. Well, again, thank you for a very interesting, stimulating presentation, and we were grateful that you reached out to us to come today. If people have additional questions, I think we're at the hour. I could be wrong. I think it's 1:45 is at the hour. Feel free to reach out to Tim directly, or if you have a few final questions, go ahead and put them in the chat now. We'll try to address them, but I don't see anything there. So thank you so much, Tim. I really, really, really appreciate it.
It was
Linda?
Really a fascinating talk, really nice.
Thank you very much. And thanks for the opportunity to speak.
Thank you for coming, everyone.
Enjoy the rest of the day.
Too. Bye-bye.
Bye.